Welcome, Mindsetters. It's a fantastic day, and I know it was raining and hailing, and now you are here and tuned in for some maths literacy. I just want to say this show is proudly sponsored by MTN SA Foundation and endorsed by the Department of Basic Education. I'm here with Claire. How are you?
Fine, thanks. How are you?
Good, thank you. We've never worked together, so this is our first time as newbies here, and I just want to say it's awesome to be doing the show with her, and I'm really, really excited. Do you want to say something about what we're doing before I explain all our things we have to say?
Yeah, just that's our plan for today is we're going to be focusing on shape, space and measurements.
Okay.
So also quite a big section of the Maths Lit syllabus, so some awesome questions that are coming up.
Awesome, Claire. So I just want to tell you guys about our Be a Bright Spark competition. And I know there was stuff about how we must enter and you could win this and this, so I'm here to clarify on exactly what you need to know and what's coming up. So you entered the Be a Bright Spark competition, right? And you bought the book or the app or something like that. And it was also to win a Chevrolet Spark L. And now the draw is finally coming down, and it's this Sunday, the 23rd of November, and you could be the lucky mindsetter who wins one, which is going to be really awesome. So stay tuned and keep your eyes peeled for this Sunday because the draw is coming. And don't stress. If your name's not called out, you can still stand a chance to win 3 of the other draws that are coming up. So don't worry about it. I also just want to tell you where to find us, and that's at facebook.com/learnextra with an X, or Twitter @learnextra, and we're going to post all the details on our Facebook page. So guys, get into it and get stuck in. So have a great show. I'm going to be here all the time, and Claire's now going to take it away. Go for it.
Awesome. Thanks, Megs.
No props.
Well, as said, we're going to try and cover as many questions as we possibly can with regards to space and shape. So just to give you an idea of what kinds of questions we're going to have a look at, all the notes obviously are on the website. So if you want to go there and have a look at it, you can do so. So just in terms of what we're going to try and cover, we've got questions relating to conversions, perimeter, area, volume, capacity, BMI, which is body mass index, and then calculations involving speed, distance, and time. So without further ado, we're just going to jump straight into that, because if we're going to try and cram as much of that as we possibly can in order to make this a worthwhile time for you while you're watching. All right, so before we start with any of the hectic and complicated calculations, I just want us to take a minute just to go back down to basics and make sure that we are comfortable with being able to do some conversions using the metric system, so converting from centimeters to meters, etc. All right, so let's jump straight into the first question. So when we do the conversions, I always work with my go-to rule, which is you might know it as the King Henry rule, and that is knowing to how many centimeters are in millimeters, etc. If you learn this little rhyme, which is on the screen behind me, then it makes conversions much easier to do, and it becomes like a reference so that you've always got that in your exams. So the way I remember it is King Henry died a miserable death called measles. Some other people have various other little acronyms in order to try and remember it. But basically what each of those symbols means is it stands for some form of metric system unit. So we've got millimeters, centimeters, decimeters, meters, decameters, hectometers, and kilometers. So the most common ones that we normally use with Maths Lit will be your kilometers, your centimeters, meters, and millimeters. But you never know, you might be asked a question with regards to the others. So when it comes to converting, if we are asked to convert in this first question, it asks us to convert 500 centimeters to 500 centimeters to meters. In that case, you might know it offhand that we know that there's 100 centimeters within a meter. Or alternatively, if you didn't know, what I then say is, all right, it's going to take me 2 jumps, which means that I need to divide by 10 and then I need to divide by 10 again. So in other words, in total, I would then have to divide by 100. Okay, so all right, so first question, nice and straightforward. So if you take 500 and you divide it by 100, our answer there comes out to be 5 meters. Exceptionally important that we do the units for these questions, because when you're doing the conversions, obviously we need to know what did we convert to. Okay, so it's really, really important that you put that unit in when you answer these questions. Right, let's look at the next one, 15 kilometers to millimeters. So once again, if you go back up to your King Henry, so I need to know how many millimeters are there in a kilometer. So if you don't know it off by heart, using your rule, if I count how many jumps there are, there's 1, 2, 3, 4, 5, 6 jumps in order to get from kilometers to millimeters, which means that if there's 6 jumps, those 6 jumps then represent a million, because a million has 6 zeros. So in 15 kilometers, 15 multiplied by 1 million, okay, will get us to our millimeters. So that's 15 million millimeters. Okay, last question, just with regards to length. Convert 120,000 centimeters to kilometers. All right, so scrolling back up. So once again, centimeters to kilometers. Okay, so if we just have a look and see how many jumps we've got there. So if you know it off by heart, great. If you don't, there's 1, 2, 3, 4, 5 jumps. So in order to know what I'm going to divide by, 5 jumps means that we're going to represent 100,000. Why? Because 100,000 has 5 zeros. So nice and easy to remember. So in this case, 120,000 centimeters divided by 100,000. Okay, if you want to, you can do it on your calculator. Hopefully you're able to do these with just by moving the comma. So in other words, in this case, we would move 1, 2, 3, 4, 5. So this becomes 1,2 kilometers. All right, so those are just some basic conversion questions, typical paper 1 type questions. Then branching, further on from that is I use the same rule, except now we're going to look at how we then convert area conversions and volume conversions using the same concept. So when it comes to converting area, remember area is a 2-dimensional concept. So you'll notice that instead of each jump being times by 10 in the previous case, now obviously each jump is going to be times by 10 squared or times by 100. All right, when we look at the volume calculations, each jump that we do is, instead of being times by 10, it now becomes times by 10 squared or multiplying by 1,000. Why? Because it's a 3-dimensional concept. All right, let's go back to those area calculations. Okay, so once again, if we just use your King Henry just as a reference, let's look at the first question. Convert 55,2 centimeters squared to millimeters squared. Okay, so looking at our conversions, if we were converting from centimeters to millimeters, it would just be multiplying it by 10, whereas in this case, it's going to be multiplying it by 100. So 55,2 multiplied by 100. All right, so if you move a comma 2 places, that gets you 5,520 millimeters squared. All right, now maybe some of you are looking at it and thinking, why are we looking at such easy conversion questions? I'll tell you why. Because when we start getting involved in the more complicated ones, often these little calculations come in there and thereabouts. And if you don't know how to convert from millimeter squared to centimeter squared or centimeter squared to millimeter squared, then it becomes very difficult in order to continue with the calculations. So don't overlook the basics in terms of understanding where these values come from. Let's look at the next question. Convert 25 million centimeters squared to hectares. Okay, notice hectares, not hectometers. If we're dealing with length, they're called hectometers. If we're dealing with area, we're talking about hectares. So going back up, we're going from centimeters squared to hectares. So if you count how many jumps, it's 1, 2, 3, 4 jumps. But each jump represents dividing by 100, so, or 10 squared. All right, so if you take 25 million, all right, and we're going to divide it by 10 squared each time, and there were 4 of them. Okay, instead of me having to write that out 4 times, what I could have said is that's simply the same as saying 25 million, okay, divided by 10 to the power of 8. If you just add your 2's together, so 2, 4, 6, 8. So that means that in that situation, you would move the comma 8 places because we're dividing. All right, so if you grab, if I just move the comma, so technically the comma's at the back, so it's 1, 2, 3, 4, 5, 6, 7, 8. So it becomes just before the 2, 5. So in this case, your answer then is 0,25, and it was hectares. Okay, so let's move on to the volume calculations. All right, it's the same concept over and over again. So as I said, I'm kind of just moving through it, fairly rapidly. It's the same concept. If you're not sure with what I'm doing, all the reference notes, once again, as I said, are on the website, so you can then just take a moment to go through it also, just to make sure that you're clear on what's going on. All right, let's go then to the volume calculation. So as I said earlier, instead of each jump being multiplying by 10 if we're dealing with length, or multiply by 10 squared if we're dealing with area, we're now talking about converting volume calculations, which means that each jump will then be either multiplied by 1,000 or divided by 1,000, depending on which direction we go. So the first question asks you to convert 0,0087 meters cubed to centimeters cubed. All right, so if we jump back up, so we're going from meters cubed to centimeters cubed. All right, so in this case, if we count how many jumps that is, that's going to be 2 jumps. So we're going to multiply it by 1,000 and then multiply it by 1,000 again. So technically speaking, 1,000 times by 1,000, we're going to multiply it by 1,000,000. So 0,0087 multiplied by, you can do it in 2 steps if you want to. If you want to do it all in one go, that's also okay. All right, so multiplied by 1,000 and then multiplied by 1,000 again, so we're multiplying it by 1,000,000. Okay. All right, moving my comma 6 places. So this is now going 1, 2, 3, 4, 5, 6. So there's 2 places that need to be filled, which with zeros. So this becomes 8,700 centimeters cubed. All right, last one. Convert 722 millimeters cubed to centimeters cubed. All right, so millimeters cubed to centimeters cubed, that's a nice easy one. All right, so once again, if it was millimeters to centimeters, I would just be dividing by 10. If it was millimeters squared to centimeters squared, I'd be dividing by 100. And in this case, because it's a volume calculation, I'm going to divide by 1,000. All right, so 722, dividing that by 1,000. All right, and we get 0,722 centimeters cubed. Okay. All right, so as I said, just keep that in the back of your mind, because those, as I said, are very important when we come to the more complicated questions. I'm going to assume now that you know how to convert length, area, and volume. So when we get to those steps, we're then just going to fly over them as if they didn't even happen, because we're comfortable with those calculations. All right, let's get to something a little bit more exciting. So what other kinds of questions can they ask us in space and shape? Well, as I said, they're going to ask us conversion questions. They're going to ask us stuff on perimeter. They're going to ask you things on area and volume. So those generally are the 3 big concepts that you need to understand and be able to tackle. So we're going to look at perimeter to start. So the difference between the perimeter of a shape and the area of the shape, remember, is that perimeter is the distance around a shape, whereas the area is the flat space that it covers. In other words, the space that it covers on a 2-dimensional plane. So when we look at this question, it says that the local primary school is putting on their end of year school concerts. Okay, that seems to be a common trend. If you spend some time on Facebook and you spend some time looking at all your friends and aunts and uncles that are attending all the school concerts. So the diagram that's given below is a sketch of the school stage, and they ask us to calculate the perimeter of the stage, and they want it in meters. All right. Where necessary, you're asked to use calculating pi as being 3,142, and then they very nicely give you the formula that circumference equals pi multiplied by the diameter. Okay, so just tackling that. If you have a scientific calculator and you have a pi button, you obviously are more than welcome to use that pi button. However, if they ask you to use pi as being 3,142, okay, then use pi as being 3,142. There's no reason why you can't. You're not going to get any less marks or more marks if you use the pi button on your calculator. If you don't have a scientific calculator, obviously that's where it's aimed at. In other words, you can then just punch in 3,142, which is just an approximation of pi correct to 3 decimal places. All right, so as it stands, we're asked to calculate the perimeter of this particular stage. So in other words, if I'm standing over here and I had to walk around the stage, I want to know how far I've walked in order to get back to where I started. So some of the measurements we've been given, however, I don't know that measurement and I don't know that measurement. Okay, so those are the 2 little calculations that we're going to need to do. So if we just look at the type of shape that we're dealing with here, we've pretty much got a rectangle and we've got a semicircle. So to calculate that length, that will simply be opposite the other side, which is then the 10,1 meters. Right? What we then need to do is we need to think about how we're going to calculate the circumference of that part of that particular shape. And that's where the formula comes in that they've very nicely given to you. So they tell us that to calculate circumference, that you're going to work with pi multiplied by the diameter. So the diameter. What's the diameter? What's the radius? Remember, the diameter is the distance from one end of the circle to the other, whereas the radius then is half that distance. So if you have a look then at that particular question, what I need to know is I need to know what is that distance. Okay, and it's there, it's in that question, it's in there, it's just hidden a little bit. You just need to think a little bit about what is that measurement. So I think I'll give you a minute just to think about that.
Okay,
Megs?
no problem. Guys, have a fantastic break, and we'll see you straight afterwards. Welcome back, Mindsetters. Hope you had a great break and now you are ready and in time to tackle some maths literacy. But before I hand over to Claire, I've been told that we only have 179 likes to go on Facebook. So come on, guys, get sharing, get everything going with your friends. I promise you, we only need 179 until we reach 100,000. So also, a really cool competition we have going here is that all you need to do is enter Curio. So you go to q.na, and then all you have to do is enter the code, which is learn, and it's for free, so you don't have to pay anything. And then you think to yourself, when is the date and the time that we could be at 100,000 likes on Facebook? And then all you get is, all you have to do is that, and then you get free airtime. So that's really, really cool. And please get entering. We only have a few likes left to go, guys. So please help us and share our page for learning, for your friends, for anyone, just so we can get those little bit more likes, please. So I'm going to hand over to Claire in my sheer desperation, and she's going to take it over with some more maths literacy.
That's excellent. Thanks, Megs. All right. So just before the break, we were having a look at the question that was asking us to calculate the perimeter of the particular school stage. And we got to the point where we needed to find out the length of that orange line. In other words, we needed to find out what was the diameter of the semicircle that had been given. So hopefully you figured it out. If not, let's go have a look quickly at what we've got. So at the bottom of the screen, you will see that they tell us that the distance from the one side to the other of the stage is 16.4 meters. We know that that distance is 2.2 and so is that distance. So if we add 2.2 together and subtract it from the 16.4, then that will tell us our diameter of our semicircle. So let's calculate the diameter. So in this case, we're going to take, right, so the diameter is 16.4, which is the distance from the one side to the other, minus 2.2 multiplied by 2, or 2.2 plus 2.2 if you prefer that. So to calculate the diameter, 16.4. Right, once again, if you want to grab your calculators, you can. Let's try and do this one in our heads. So 2.2 multiplied by 2 is then going to give us 4,4. Okay, if you don't believe me, grab those calculators. And if we work out then what 16.4 minus 4.4 is, okay, I'll do it on the calculator just to be safe. All right, so 16.4 minus 4.4, which tells us that our diameter is 12, and in this case, it was 12 meters. Right, now, what was the point of that? Well, remember we said that we need to know what the diameter is in order to now calculate the circumference of the semicircle. So according to the formula that's given to me, to calculate the circumference of a full circle, you would take pi and multiply it by the diameter. So let's start by doing that. So if we calculate now what the circumference is, all right, so circumference using the formula given was pi multiplied by the diameter. We're going to use pi as being 3,142. And then the diameter that we've calculated in this previous calculation is multiplying it by 12. So on your calculators, 3,142 multiplied by 12. All right, press your SD button. So that tells us that the circumference of the circle is 37,704. So 37,704, and it would be meters. Now, it's important that we understand that that is the full circle. All right. We want the full circle. We only want half the circle because we're dealing with a semicircle in this case. All right. So in that case, obviously, if you're trying to work out what the length of a semicircle is, we're simply going to then take that 37,704 and we're going to divide it by 2 to get the semicircle. Right. So dividing it by 2. Okay. So hopefully you've still got that on your calculators. All right. And so if I just divide by 2, then the semicircle then comes out to be 18.852. All right, I'm not going to round off anything just yet. Okay, so if you're wondering why I'm not rounding off to 2 decimal places, because your teacher always tells you to do so. Okay, I'm not quite done yet with my calculations, so hence the reason I'm just going to keep that as it is in order to now calculate the perimeter of the entire stage. All right, so that was the semicircle now that we're dealing with. Okay, now that we've got all the measurements, I'm going to fill that in. So now this distance that we've just calculated, okay, let's just delete that. So the distance that we just calculated in this case is 18, was it 852? Yes, it was. Okay, 18,852 meters. All right, and now that we know all the different measurements, now we simply just have to add all of them together in order to calculate the total perimeter of our stage. So you're going to grab your calculators. We're going to add the 10.1, the 2.2, the 18.852, the 2.2, the 10.1, and the 16.4 along the back of the stage. All right, so you probably want to write all that down. Okay, let's see how we go. So this is now the perimeter, which is the question that they wanted us to work out. So it was 10.1 plus 2.2 plus 18.852 plus another 2.2 plus 10.1 plus 16,4. All right, so all of those, whack them into your calculator and let's see if we can get the final answer then for the perimeter. All right, so 10.1 plus 2.2 plus 18.852. All right. Okay, just checking. Plus another 2.2 plus 10.1. And lastly, the 16.4. All right. So our total perimeter, now I'm going to round off to 2 decimal places because now I've calculated the final answer. So if I have a look at that, 8,852, that 2 is not going to affect the 5. So in this case, it's simply going to be 59,85. So 59,85. And in this case, it's meters because it's perimeter. Remember, perimeter is a length. Okay, so it doesn't need a meter squared or meters cubed. That would be area and volume. In this case, if it's just a distance, then it'll simply be either centimeters, millimeters, or meters. Okay, so that was a bit of a handful or a bit of a mouthful. So let's just quickly run through it again. Okay, what didn't we know? We didn't know the diameter of the semicircle, but they gave us enough information in that question in order to then calculate it. We needed the diameter in order to calculate the circumference. And remember, in that case, don't be caught out because chances are they are going to give you the formula for a full circle when you only needed a half a circle. So once you've calculated, we divided it by 2. Once we know all those dimensions, we then add them all together and we get our total perimeter. And in this case, as I said, it came out to be 59,85. Remember that number because we're going to need it in the next question. Okay, so next question, question 2.2 says, the school wants to put metal strips around the edge of the stage, and the metal is we're told that it's sold in 175 centimeter strips at a cost of 89 Rand per strip. Calculate the total cost in order to complete the project. Okay, so let's just understand the story. So chances are they've built the stage and then maybe they want to attach, for example, a curtain around the front, or maybe they want to make sure that it's neatly edged properly. So they're going to put these little strips of metal around in order to finish off that stage. And what you're asked to calculate is how many of these metal strips are going to be needed in order to now work around the perimeter of that particular stage. So they go to Builders Warehouse or they go to whatever, Macro or whoever you're going to sell, they'll find these particular metal strips, and they find out that the metal strips are sold in 175 centimeter long strips. So it doesn't come in one long strip that we can just kind of maneuver it away around the stage. It comes in specific sizes that we then have to buy a certain amount of them in order to make sure that we cover the entire perimeter. All right, so Once again, what's very important, I calculated the perimeter in meters. However, in this case, the strips are sold in 175 centimeters. So either you've got to convert your perimeter to centimeters, or you've got to calculate your metal strips in meters. So you can decide which way you want to do it. It doesn't matter. You'll still get the same answer, but you need to make sure that you're working in the same unit. In this case, I'm going to take the 175 centimeters, and I'm going to convert it to meters in order to match up with my perimeter. So going back to those first questions that we did, and that is, how do we convert centimeters into meters? We know that there are 100 centimeters in a meter, which means that we're going to take the 175 centimeters and we're going to divide it by 100. All right, which means each of these strips is now 1,75 meters, which makes me feel much better about life, because so is my perimeter is now in meters as well. So what was the perimeter? Okay, so the final answer for that question was 59.85. So let's just make sure we write that down. Okay, so the perimeter was 59.85 meters. Okay, and as I said, I'm happy because now I've got meters, and I've got meters, which means I'm working in the same unit, which means I'm going to get the correct answer. So I need to calculate how many 1.75 meter strips will fit into the perimeter of 59.85 meters. So on your calculators, you were going to have to work out the number of strips as being 59.85, and we want to divide it by 1,75 to work out how many will fit into the perimeter. Okay, so on your calculator, so what are we calculating here? We're calculating, this is going to give us the number of metal strips that we need. All right. Okay, so on the calculator, 59.85. And we're going to divide that by 1.75. Okay. And if I press the SD button, that tells me that the answer is 34.2. Okay, now, this is my favorite part about Maths Lit, because we have our own rules. Okay, and that is, if you were doing a straightforward maths calculation and I said to you, round that number off, you would tell me that it's comma 2, therefore it rounds down to 34. However, maths literacy, we make our own rules up, and that is, we have to think about whether we are rounding up or down, because the context dictates what to do. It tells us what to do. So in this case now, you've decided, or we've calculated, that we need 34.2 strips. So if I go into the store and I only buy 34, and I come back and I measure it out and I put all the strips down, there's going to be a section of that stage that's not going to have a metal strip on it. So even though maths rules say you have to round down to 34, maths lit rules say if you only buy 34, you're not going to have enough. In which case, instead of rounding down, we're going to round up and say that we're going to buy 35 metal strips. Okay, so I love that. Always catch the maths kids out with that one. So 35 metal strips. All right, that's not the end of the question. Remember what the question said? It said we needed to calculate the total cost. So now that we know how many strips we're going to buy, each strip is 89 Rand 95. So the total cost of this project is going to be 35 multiplied by 89 Rand 95 cents. Okay, our answer is going to be in Rand. Grab your calculators. So 35 multiplied by 89 Rand and 95 cents. Okay, so quite an expensive project. So our total cost in this case is going to be 3,148 Rand and 25 cents. Okay. I know last week we had a look at financial maths as well. Understand that when it comes to paper 2, you're going to have an integration of all the different concepts and topics into various different questions. So even though we're specifically trying to tackle some of the measurements questions here, you are going to every now and then get chucked in with a financial maths question as well. So just be aware of that. Okay, right. Let's grab the next question. Okay, well, this looks exciting. Okay, so it says, in the morning, people are encouraged to eat a good healthy breakfast such as cereal. Bokoma Weet-Bix, which obviously is a type of cereal in our country, is packaged in such a way that it aims to reduce the chance of each cereal block from breaking while being carried and transported. The packaging company wants to use as little cardboard as possible to make the boxes, and they do this in order to reduce their costs. All right, and they also want to try and help save the environment. In other words, the less wastage there is, the better. So the picture below shows us the dimensions. Just important to understand, dimensions simply means the measurements, the length, the breadth, and the height in this case, because we're dealing with a three-dimensional shape. So if they ask you a question such as give the dimensions of a room, then the chances are they're asking you for the length and the breadth. So the word dimension specifically refers to the length and the breadth and the height of this particular box. Okay, so there's our box. Looks good. Bit of milk, bit of sugar. Sounds like a good idea. And then they give us formula. So once again, this is a typical paper 2 question. Paper 1, what they normally try and do is they'll give you the formula within the question so that you know which formula to apply. In paper 2, you get a box of information. They will give you 3 formulas, maybe more, maybe 4 or 5 formulas, and then you have to pick the appropriate formula in order to tackle each of the questions. So in question 3.1, it's asking us to calculate the surface area of the box, and we're going to obviously work with an answer in centimeters squared. So if we go back up then and have a look at our formula that are given, okay, they give us an area formula. They give us the surface area formula as being 2 length times breadth plus 2 length times height plus 2 breadth times height. So just so we understand where that formula comes from, when you think about a box has got 6 faces. It's got a top and a bottom, it's got a front and a back, and it's got a left and a right. So when you look at those calculations, there's 3 calculations. Why? Because there's 3 pairs of sides that we're going to have to calculate. Why is that important? Because you might get a calculation where, let's say, for example, they told you that the box didn't have a lid. So you need to know how to manipulate that formula in order to fit the particular context that you are then having to deal with. In this case, we're talking about a box of Weet-Bix, which means obviously we need a top and a bottom, a left, right, and a front and back, okay, to make sure that everything's packaged properly, and then we're going to calculate the surface area. Okay, they want us to work in centimeters squared. So if we just quickly scroll back up, another catch. So we've got 12 centimeter breadth, we've got a 25 centimeter length. However, that 200 millimeters needs to be converted into centimeters in order for us to then calculate our answer in centimeters squared. So 200 millimeters, once again, we did this in the first calculation. If I want to convert millimeters to centimeters, I'm going to divide that by 10. So that means that the height of this box is 20 centimeters. Okay, jump to the calculation then. So here's our formula. All right, so I'm literally just plugging the length, the breadth, and the height into the particular places in the formula. So our length in this case, so I'm just going to write these down the side just so that we know what we're dealing with. So our length is 25, our breadth would be the 12, and then our height will be the 20. Okay, so our length is 25 centimeters, our breadth, pardon me, was 12. Okay, and our height, which we've now converted, is 20. Okay, so, right, grab your formula. Very kind of them to give you that formula. So we've got the surface area is 2 length multiplied by breadth, so 25 multiplied by 12, plus 2 length multiplied by height, so 25 multiplied by 20, plus 2 multiplied by the breadth times by the height, so 12 times by 20. Okay, use your mark allocation as a good guideline as to how much information they want you to show. It's worth 4 marks. So in that situation, you probably want to work out each of those brackets and write out your simplified answer. And then once you've got your 3 answers, then you're going to add them all together and you're going to get your final answer, and your final answer will be in centimeters squared. Okay, so literally all you've got to do now is grab those calculators, punch in those 3 different calculations, get your 3 different answers, add them together, and we're A for away. Next.
Time for a break?
Time for a breather.
I think so too. But before we go, I just want to tell you about something about our K53. So I know December's coming up and exams are over, and you know, December's a fantastic time with your friends to relax, but remember to do so responsibly, because drinking and driving can change not only your life or your friend's life, but other road users' lives forever. So don't let a friend drink and drive. Be a bright spark and save a life. Have a good break. Welcome back, grade 11s. It's time to get into it, and I hope you took my message very seriously because, like I said, don't let your friends drink and drive. So I just want to tell you, it's our last segment. We're going to get going with our maths lit, and then we're going to say goodbye a little bit later. But where to find me is facebook.com/learnextra with an X, or Twitter @learnextra, and we've posted all the details that you need to know on our webpage. So go have a look, and I'm going to hand it over to Claire.
Thanks, Megs. Good. Well, Esther, I hope that you have a little bit of a breather, had time to think about the question just before the break, and you've punched into your calculators. I've got the answer on the board, so let's just quickly have a look and see if your answer is the same as mine. So if I simplified each of those brackets, I got 600 for the first, 1,000 for the second, and 480 for the last bracket. And if I add all of those together, I get 2,080 centimeters squared. So just give you an idea of possibly where your mark allocation might be allocated for this particular question. So chances are you would get 2 marks, let's say, for substituting the values correctly into the formula. You might then get 1 mark for simplifying each of those brackets, and then your final mark would then be for your answer with the correct units. Okay, once again, very important that we have those units in there so that we know what we're calculating. All right, so I'm going to jump around a little bit because I know we're running out of time in terms of we've just got so many questions and not enough time to just get to all of them. So we've tackled a little bit of conversions, we've tackled a little bit of surface area, and I want us to now quickly have a look at some volume questions and capacity. So just something to think about. Okay, the difference between a volume and a calculation and a capacity question. Let's see where we can find one of those. Right, so difference between the two. So generally speaking, capacity is normally asking for you for an answer in liters or milliliters. In other words, the capacity of an object is literally how much liquid can fit in that particular container, whereas volume is simply how much space does that container occupy. So it's a slight difference between the two. Sometimes people interchange the word volume and capacity, but there is definitely a difference between the two. So generally speaking, we look at the volume first, and then we're going to work out the capacity. So question 4 on your notes tells us that the diagram below shows a feeding trough, okay, that is used to feed cows. They tell us the diameter of the trough is 0.8 meters and that the length is 150 centimeters. Once again, I hope alarm bells are going off in your head with regards to meters and centimeters, different units, so we'll need to tackle that in order to calculate where we're going. Right, the question says calculate the capacity of the trough in liters. And then once again, the information that's given to you tells us to calculate the volume of the cylinder would be that, and that to calculate capacity, they give us a little bit of information about how to convert volume into liters. All right, so if we just look at the type of shape that we're dealing with here, we're dealing with a cylinder, but once again, only half the cylinder. So the formula that's been given to you is a full cylinder. All right, so we're going to calculate it using pi as being 3,142, but keep in mind that that's going to give us the whole cylinders, whereas we only want half of it. Right, what do we need? We need pi, we've got that. We need the radius. They tell us in this case that the diameter is 0.8 meters, which means that our radius would have to be half the diameter. So if you divide that by 2, that's then going to give us 0.4 meters. The height is given to us in centimeters. Now, the question asked, probably that you want to ask yourself is, well, what do I convert to? Do I convert to centimeters cubed, or do I convert to meters, or do I convert to centimeters? Once again, it doesn't matter, provided that you know how to convert volume calculations, which is what we tackled in that first segment. So it really doesn't make a big difference. However, personal preference, if I know that I'm going to convert from meters cubed to liters, which is the reason why they've given me this information, then my inclination would be then to calculate the volume in meters cubed in order to then convert it easily into the capacity value that's been given. So instead of that 150 centimeters being in centimeters, I'm going to take that 150, I'm going to divide it by 100. All right, so 150, we're going to divide it by 100. All right, which means that the length is now 1,5 meters. Talking about length, I'm technically talking about the height of the cylinder. Okay, the height simply just means if I had to stand it up on its circular base, how tall would this thing be? And in this case, it would be 1.5 meters. So I've got my radius, I've got my height, I've got pi as being 3,142. So I'm going to start by calculating the volume, and then I'm going to convert it into capacity. Okay, so here's your formula. So volume equals pi times by the radius squared, okay, times by the height. Right, pi is 3,142, or your pi button if you wish on your calculator. The radius which we've recalculated was 0,4. and I'm going to put this in a different color, squared, ladies and gentlemen, which means if you don't do that, then you're obviously going to not get the correct answer. So just one of the things that sometimes people forget to do is square the radius. And then the height, which we calculated in meters, is now 1,5 meters. Right, calculator time. Right, so on your calculators, we're going to work out 3,142 multiplied by 0.4 squared. If you don't have a scientific calculator, you would simply say 0.4 multiplied by 0.4. And then we're going to multiply it by 1.5, which was the height. All right, so that now tells us the volume of the trough if it was a full cylinder. Okay, so 0,75384. Okay. I'm calculating the value in cubic meters because all my values were in meters. But once again, this is the full cylinder, whereas I only want half. So I'm going to take my calculation. I'm then going to divide by 2, and that's going to give me the volume of the trough, or the semi-trough, if you want to call it that, or the semi-cylinder. All right, so in that case, it's now 0,37692. Okay, I'm going to write out the full value. So 0,37692. And that's again in meters cubed. All right, now, how does that help me? So I've now calculated the volume. Okay, so this now is a volume calculation that we've just done. Okay. But once again, I'm not interested in the volume, I'm interested in the capacity. So I've now got to look at the information that it's given to me, and they tell me that 1 cubic meter is the equivalent of 1,000 liters. Okay, so if 1 cubic meter is 1,000 liters, all right, then I need to know what is 0,37692 meters cubed in liters. Okay, so you're going to take that value, all right, and you're going to multiply it by 1,000. Once again, notice I haven't rounded off anything because I haven't calculated my final answer yet. So try and keep as much accuracy as you possibly can. So don't round off anything until you get to your final answer. So we're going to take the 0,37692. We're going to multiply it by 1,000. All right. 0,37692 multiplied by 1,000. Okay, you can do it on your calculators if you want to. All right, so my value is still there, multiplying it by 1,000, which means the capacity of this particular trough is 76,92, and it would be liters. Okay, so this is the capacity. Okay, so technically speaking, it's very similar to volume in that you have to calculate the volume first before you can calculate the capacity. Okay, but once again, just be aware that there is a slight difference between the two. Good. Okay, next question. All right, this is one of my favorites. It says, a standard can of cold drink, okay, Coke, Fanta, Sprite, Coke Zero, whatever you want to call it, all right, has a capacity of 330 milliliters. Used to be 340, now they're 330 mils. They tell us the diameter of the can is approximately 6 centimeters, and you're asked to determine the height of the can correct to your the nearest whole number. So we're going to round off our final answer to the nearest whole number. All right, so why do I like this question? Because normally, when we give you questions, we give you the radius, or we give you the diameter, we give you the height, and we ask you to calculate the capacity. In this question, I'm giving you the capacity, and I'm asking you to work backwards in order to calculate the height. Okay, so it's not any more difficult, let's say, it's just going a different direction. In other words, starting with the answer and working back to the original dimension. So we're given the diameter, we know that the capacity of this particular can is 330 mils. Okay, so let's just write that down. All right, and now I need to basically work out what the height is. So we're going to use the volume formula for the cylinder. They tell us that volume is pi multiplied by the radius squared multiplied by the height. And then this is the crux of the question. So 1 centimeter cubed is the equivalent of 1 milliliter. Right, so why do I need to know that? So remember the previous question, we got to the answer as a volume calculation, and then to convert it into a capacity, they told us that so many milliliters was equivalent to so many cubic meters. So now we're going the other direction. Luckily, it's a nice straightforward calculation in that it's a 1-to-1 ratio, which means for every 1 milliliter, that is the equivalent of 1 centimeter cubed. So if I ask you to convert this capacity into a volume, then if 1 millimeter is 1 centimeter cubed, then 330 milliliters will simply then be 330 centimeters cubed. Okay, so a nice straightforward conversion into volume. Why do I need that? Because now I'm going to take that volume and I'm now going to substitute it into the particular formula that we've been given. Okay, so let's have a look at our calculation then with what we know. Right, volume equals pi multiplied by the radius squared multiplied by the height. We don't know the height. Okay, that we don't know. Let's put in another color so we understand. Okay, so we know the volume. We've just calculated that the volume is 330 centimeters cubed. We know pi, which is 3,142. We don't know the radius because they've only told us the diameter. But once again, you should know, if you know the diameter is 6 centimeters, then obviously the radius will simply be 3 centimeters because it's half of 6. Okay, so substituting the 3 squared in, don't forget the squared, and then we're multiplying it by the height. Okay, so a little bit of manipulation. On the right-hand side of your equation, you've got 3,142 multiplied by 3 squared multiplied by the height, and we want to get the height on its own. So to calculate the height, we're going to take this 330, and we're going to divide it by everything else except for the height. In other words, 3,142 multiplied by 3 squared. If you want to, you can calculate that first and then take the 330 and divide by that answer, or once again, you can just put it in and you'll get your manipulation mark. All right, so on our calculators, personal preference, you can use the fraction button if you want to. I know a lot of the guys in my class like that way, so I'm going to use that way. So 330, and then we want to divide it by 3,142 times by 3 squared. Okay, remember, if you don't have a scientific calculator, then just remember to say multiply by 3, multiply by 3. Right, so that's going to give us our height. Okay, so our height in this situation is going to be 11,669. So 11,669, etc. All right, and if you remember what the question said, it said that they wanted you to work out your answer to the nearest whole number. So in this case, we want to round off to the nearest whole number. I'm using maths rules. So that 6 is simply going to change this now to 12 centimeters. All right, which means the height of your average Coke can, your average Fanta can, your average Coke Light can, whatever, is going to be 12 centimeters. So just think about that for a second. I mentioned this last week. You need to have your maths lip brain on, in that when you look at a particular answer, you need to think to yourself, does that make realistic sense? So if you can visualize roughly what 12 centimeters is, okay, it's approximately that height, that looks roughly what a Coke can would be. So then that's a pretty feasible answer that you've calculated. All right, so why do I like that question? I'll say it again. Because instead of giving you the information and the radius and the height and asking you to calculate the capacity, I give you the capacity and I ask you to work backwards. I could have, if I was really nice, given you the height and asked you to calculate the radius, in which case that would also involve a little bit of manipulation. So don't be intimidated by the fact that the question's not asking it in the usual way. Be comfortable with the fact that they could ask it going forwards and going backwards. All right, let's try and see if we can just squeeze one more question in. Okay, let's quickly do a time calculation. So involved in shape and space is obviously information with regards to time. If you've got a scientific calculator, there's a very cool button on your calculator that helps you to work with time. If not, you're just going to have to take it step by step to calculate the answers with regards to the questions. So this question, let's quickly just scan through it. It talks about the Powerade Doozy Canoe Marathon. So a lot of people would have finished the 94.7 cycle challenge yesterday. So this is another one of those races where us very active South Africans get involved. It's a canoe marathon and it's regarded as one of the toughest canoe events in the world. It's alternated annually between the singles and pairs format. So 1 year they go singles and the other ones they go in pairs. But it's always held over over a 3-day period. Each day's distance has a defined start and a finish. All right, the first day's distance is 42 k's, which includes a portage section of 15 kilometers. Portage means that you have to carry the canoe over land because there's an obstacle in the river. And then they tell us that there's a shorter portage section, etc. I'm going to jump straight down to the last question. And that is, they tell us about a guy who he won the Doozy Canoe Marathon. They tell us that the distance was 122 kilometers and that his time was 8 hours and 8.01 hours. And you're asked then to calculate his speed. So just very quickly, just a reminder, if you're calculating speed, we take the distance and divide it by the time. So if I take 122 and I divide it by 8.01, then my answer will be in kilometers per hour, and that will be the speed at which this guy has done the canoe, the Doozy Marathon. Okay, so I think we're trying to squeeze in everything that we possibly can. I hope it's been useful. I hope that some of the stuff that we've tackled today will kind of help you or just give you a bit of an extra edge over everyone else who's going to be writing the exams. I wish you all the best of luck. Megs?
Ready, Claire?
I think we're done.
Okay, no problem. Thank you so much, Grade 11. It's been a fantastic show. I hope you learned everything. You know what's going on. If you have any questions, again, just hit us up on Facebook. I'd like to say thank you to MTN SA Foundation for sponsoring our show, and it was also endorsed by the Department of Basic Education. So I hope you guys have a blessed evening. That's love from me to you. And what do you think we could do for questions and advice for maths?
I just think if there's any other questions, they just need to have a look at that website, have a look at all the notes are there, the memos are there. They can literally just go on, and if there's any other questions, then you can always obviously post it on the Facebook pages and we go from there.
Okay, thank you so much, my
You're
love.
welcome.
But again, guys, you know what? Time to focus. Exams are almost over, and that stretch for summer is hitting there, guys. So you know what? Take a step back, do your exam revision, and do your notes. So I just want to say, it's my last show of the year. Sigh, little teardrop. But I hope you guys have a great, great time in December, and you have great jewels. And I'll speak to you again in the new year. It's been a very great year, and I just want to say thank you very, very much. Thanks, Mom. Thanks, Dad. See you again soon. And that's a wrap. Bye, guys.